Okay, this is 7.1 of precalc day 2. Day 2 starts off with not the simplifying, that was yesterday or the day before. Today we are going to verify. And to verify identities, something has to happen. You need to make one side look like the other. You're not allowed to cross the fence. You're not allowed to do one thing to the side, do to the other. You're only allowed to change with the idea that you have identities that are exactly equal to each other, 4 quarters for a dollar, 10 dimes, that type of thing. And you're going to change a side until it's reduced. Most of the time it's basically reducing, a lot of times, but you're trying to make it look like the other side. So here's the cool thing. You all know the answers. Because the answer is the other side of the equal sign.
Yeah.
So you just got to get there.
Oh, yeah.
And this, guys, would highlight the fact that all year long, I'm not caring about the answer. How do you get to that answer? And that's where the important part is. You can't make stuff up. You have to use mathematically legal operations to make it work. And so, you're always going to start with one side, 99% of the time. There's going to be one problem, we're going to do both sides. But you're just going to choose one of your sides. And the side that you're going to choose is what we're going to say is the more complicated side. The side where you have fractions that can be added together by common denominators. Stuff like that. So you start with that side, and you use your known identities. Right now, we only have a few. Starting tomorrow and the next day, you'll have more and more of them. So therefore, you'll be able to do more and more verifying identities. And to make things a lot easier, you're going to probably convert a lot of things into sines and cosines. It just makes things easier for us. And anytime you see something that's a sine squared, or a cosine squared, or sine squared plus cosine squared, you can change it. But you also should recognize that there are identities for secant squared, cosecant squared, tangent squared, and cotangent squared, right? So all 6 of them are formed with those Pythagorean identities. We only were supposed to technically kind of remember the one because the others can be built from it. And so when you see something like that you want to get rid of, take out sine squared plus cosine squared equals 1 and change it. Okay, our first one. Now guys, every single one of our problems for our notes are kind of giving us a hint of a certain move or a certain way to make things happen. So this one's telling us rewrite it in terms of sine and cosine. So when we're doing that, you're going to be able to solve it. But eventually, they're just going to say, verify. And say verify, you just have to do it. And so, we have our identity. Hopefully everybody recognizes that you got cosine theta times secant theta minus cosine theta equals sine squared theta. Which side looks more complicated? The left side. So that's the side that we're going to work with. It says, in our directions at least, if you change them to sines and cosines, you might have an easier time. We have a secant. A secant is the same as, yes, it's 1 over cosine. So cosine theta times 1 over cosine theta minus cosine theta is equal to sine squared theta. I am going to either one of two things. Keep bringing sine squared theta down, or I'm just going to keep in the equal sign knowing that it's going along for the ride, but at the end I'll bring it back to verify that sine squared theta is equal to sine squared theta, and we're happy. That's most likely what I will do. What do you think the next step is now? Distribute the cosine. Cosine theta times 1 over cosine theta is 1. Cosine theta times a negative cosine theta. Cosine squared theta equals sine squared theta. Now what do I do? Oh wait, that is equal to sine squared because Sine squared theta plus cosine squared theta is equal to 1. What happens when I subtract cosine from both sides? You'll get sine squared theta. So therefore, this thing is equal to sine squared theta, which equals sine squared theta. Check. We just verified. The left-hand side was able to be made into the right-hand side. The next one says by combining fractions. That's our goal, because if you try to verify 2 times tangent x secant x equals 1 over 1 minus sine of x minus 1 over 1 plus sine x, I think you guys could see that the 2 fractions would be more complicated than the side where it's tangent and secant. Can you guys agree with that? So what should I do here? I'm going to work with the right-hand side. How do you combine fractions if they don't have a common denominator? Make one. So, first group is multiply it by 1 plus sine of x. Next one is 1 minus sine of x. You multiply by the conjugates, right? Okay. Try that. Okay, guys, so we would agree, I hope, that the tops won't change, yes? Because you're multiplying them by 1 or negative 1. Notice that I left it, guys, with the parentheses minus between them because it was a negative 1. But would everybody be okay if I multiplied the bottoms together? Sure. Now, do we remember the shortcut for these? Now you can FOIL, but this is the sum and difference. The sum and difference, when multiplied together, will leave you with the difference of squares. Okay, let's just do it the old-fashioned way. 1 times 1 is 1. 1 times sine is, or negative sine is, negative sine of x. Sine of x times 1 is a positive sine of x. And sine of x times negative sine of x is negative sine squared x. What happens to the sine of x's? They cancel. Also, on this move, which leaves you with 1 minus sine squared x. That's the difference of squares. I'm going to distribute that negative up top too. Is that okay? So I get 1 plus sine of x minus 1 plus sine of x all over 1 minus sine squared x. This equals, that equals, the 2 tangent x secant x, which equals, wait, what happens to the 1's? And that's sine of x plus sine of x is, 2 sine of x, over, cosine squared x, because solving that same Pythagorean identity. So how can I go from that to 2 tangent x secant x? I already have 2. 2 is there. Split the cosine up. 2 sine of x over cosine x. Is that okay? Would it be okay, guys, to do this? To just basically take cosine and split it to its own fraction denominator? Why is that okay? Because it's being multiplied. How do you multiply fractions? You multiply across. And what is sine over cosine? What is 1 over cosine? So 2 tangent x secant x, which is 2 tangent x secant x. Check. Done. Next one, it says prove it by introducing something extra. Now again, you can't do something to both sides. So it's not like I can add 2 to both sides or multiply both sides by 2. That will actually change the problem in a way. It would still be the same. They're still equal to each other, but it might be a little bit more difficult to prove the identities. So again, we're only working with one side. Which side looks more complicated? The fraction side or the non-fraction side?
Fraction.
Okay, so we're going to go with the fractional side. Well, the only way that I can deal with a fraction is to simplify it, or what I do to the top, I have to do to the bottom. 1 minus sine u, could I fix that or change that? Yes, what I do to the bottom, I'll do to the top, and that is 1 plus sine u. 1 plus sine of u. Again, the bottom is the sum and difference, which will lead us to 1 minus sine squared x. First one squared minus the second one squared. Difference of squares. I'm hoping that we get to that point. Makes our life a lot easier. And then what can I do on top? Distribute. What does 1 minus sine squared x, or it's supposed to be u, sorry. What does that actually become? Cosine squared. How can I get secant? How can I get tangent? I could factor out a cosine. Maybe I shouldn't have put it through, right? Oh, man. So now I'll take that cosine u back out? Does it hurt? Because now I can cancel this with the square. Guys, this is a good place to state this. You're going to hit roadblocks, or you're going to run in circles. Because you're interchanging equivalent pieces, you could end up running in circles over and over and over again. You change it one place, change it back in another place. What's going to happen is that you're either going to go circles, roadblocks, whatever. It might just be easier to cross it out and restart than erase your page. You may take up a lot of paper. As a group in class, we're going to go with what people are saying. And at that point, it might lead us to a roadblock where we have to back up or change it. Again, this is like a chess game. You think 3 moves ahead. When you do something, think about it in your head. Visualize it before you change it to see if that might be beneficial or not. And if it's not, then maybe try not to do it that way, if there's another option. Sometimes you just got to do it. So I like the fact that we cancel this, because now we get 1 plus sine of u over cosine of u. What happens here? It's a fraction. Yeah, separate to their own denominator, right? This is 1 over cosine u plus sine of u over cosine u, which ends up equaling secant u plus tangent u, and that does check out. Wait a minute, guys. What if this would have said tan u plus secant u? You could flip them, but essentially they are still the same. Next one. This is that 1% of the time, guys, that we would say you're going to use both sides. In this problem, they both look just as complicated, possibly. So what we're going to do, because it's telling us to do both sides, there's probably a way to not do both sides here. But we're going to use both sides because it's telling us to. Do you see that we could simplify the left-hand side somewhat, using almost the exact same concept that we finished off the last problem? What would that look like then? 1 over cosine theta plus 1. Well, we'll write it out. Cosine theta over cosine theta. Split them to their own denominator. Ooh, well, what about the other one? Could I multiply that by secant theta plus 1 to the top and bottom? This is not the only way to do this problem. But if you can't see anything else, maybe FOIL it out, distribute. I am not going to multiply the top stuff together yet. But the bottom would equal secant squared theta minus 1. First one squared minus the second one squared. This would equal secant theta plus 1. Oh, wait a minute. Do you guys see that secant squared plus 1? It's right there.
Yep.
Is there a way to cancel these out? Well, let's see. Wait a minute. I said earlier that if you have any of these identities squared, you can revert back to Pythagorean's identity and maybe switch them out. So let's go back to this. I want secant. Where can I get a secant by using this? Divide by the cosine. So if I sit there and divide every piece by cosine squared, would you guys agree that I end up with my 1 over cosine squared, which is secant squared? Which actually is tangent squared theta plus 1 is equal to secant squared theta. Can I rearrange that to say secant squared minus 1? And what would it equal? Tangent squared. So guess what? Tangent squared theta times secant theta plus 1 all over tangent squared theta. What happens with the tangent squareds? They cancel. Secant theta plus 1 is equal to secant theta plus 1. Check. Done. You now have enough information to do the first 2 worksheets. So the second worksheet, I would start working on that, still finish up the first worksheet, which is the simplifying worksheet. Seems like there's a lot. That means basically 3 sides of worksheet now because we probably did not start the second half of the first one. We will have an extra day in here for these identities to kind of work, but not yet. So we're going to introduce some more stuff to work on, more identities tomorrow, but then eventually there will be some time in class to work on these. Okay? So don't worry about that. Worksheet 2 can now be worked on. Have a great day.